All right, what we're looking at today is a delay effector, this is sort of an approximation of Cinema 4D's MoGraph delay effector that I've made in Chops. I'm going to walk through sort of the thinking and why I leaned into Chops on this one. You can see that the performance on this is pretty good. Right now I'm getting about 18 FPS, which is close to 24, which is what my project is running at. This is what the effect looks like without my delay setup. It's very basic. It's just a torus fall off, and it doesn't have a lot of character. The setup that I've built will not only control the position, but with a little bit of tweaking, it'll also give you a delay on this rotation as well, which really I think adds a lot to it. I'm not going to rebuild this entire scene. I don't think it's worth the time it would take to go through that, but I will step through just to show how I generated these pieces, and then I'll dive into this both the MOPs setup and the chop setup that I have that's responsible for the delay effect. To get to this point with these fractured pieces, all I've done is just use the RBD fracture material SOP. I fed in some control points. Let's go to light for a second. My background was too dark to see the points. So I fed those into the point input here. I generated some edge detail on these pieces. But what I found was when I took the high-res geometry and did this, applied some MOPs fall off to the high-res geometry, it really slowed down. And what I'm most interested in is viewport performance, and just so I can iterate on my work faster. So I try to keep my viewport performance as quick as it can go. So with that in mind, rather than taking this high-res out, I took the proxy out, which is just this last output over here. And then to get into the MOPs setup, you can absolutely use the MOPs convert? The MOPs convert, but just out of habit, I always use an assemble because it's just what I've been familiar with. Now, one gotcha on coming out of the RBD material fracture, the assemble SOP, when you create packed primitives, by default, it has this name attribute turned on, and I'm just going to come over here and show you what this, show you the gotcha here. This name, the RBD material fracture creates a name attribute on its own. See, it's got the name attribute there. So when this was on by default, I was getting 2,829 pieces out of my proxy, and out of the high res, I got a different number, 2,814. But when I turn the name attribute off, they match up, 2814, 2814. That was messing me up down the line, so I just thought it worth mentioning. So MOPs, I love using MOPs. I think Henry Foster has done the community an amazing favor by creating these tools and distributing them for free. I use them all the time on almost every project, especially coming from a Cinema 4D background. For me, it's been huge to have these tools inside Houdini. It operates on packed primitives, which you probably know, so that's why the assemble SOP. So I've got those packed, and now what I've done is I've fed these into a MOPs shape fall off, which is I've got set to torus. Now, by default, if you've ever used these tools before, if you want to preview your fall off, you'll notice that when you have packed fragments turned on, your color representation of that fall off goes away. Packed fragments are going to give you faster performance, at least in this case for me. Packed fragments are going faster, but I often will turn them off to see my viewport, or to see my my fall off. You can also, if you have those still on, you can also use the sprites and scale those down. I just don't like that. I prefer to see it on the geometry, see my fall off on the geometry. So let me turn the sprites back off, and there. That's this is how I view falloff almost all the time, so I can tell what's going on. So all I've done is I've got a torus that's scaling up, and I have some noise added to that. But you can see even now, like my viewport performance kind of tanked. And the reason for that is this packed fragments. So when I turn that back on, I'm back up to full frame rate. And then after that, I created the fall off here. Then I applied a transform, which is just got some position and rotation. Let me shorten up my amount of frames just so we can loop through faster. Yeah, so nothing too complicated here. Now I'm just going to take all these, move them over, and I'm going to bypass those. Now and for the time being, I'll disconnect them. Now there are built-in tools to give you this sort of delay, and it's actually not called MOPs delay, it's called MOPs Spring. The delay, there's a MOPs delay modifier as well, but it does something different, which I'm not gonna really get into. Now this is a solver-based solution. You can hop over here. You see this is using a in here you'll see a Spring solver which is created. This works. It works fine, but you can see, being a solver, it takes some time to cache, and my viewport performance got cut in half. So I'm down around 12 frames a second, which really isn't bad. And if you're looking for a very straightforward solution, just do this, and you can dial in your settings, and you can get oops, not 10, 1. You can dial this in, and you can get something that's a lot closer to the, or you can get something that's relatively close to the Cinema 40. I think I went the wrong way with my mass and my spring coefficient. So I'm not going to spend a lot of time dialing this in, because this is not the way I choose to work, but it's a totally viable solution if you don't want to dive into chops and mess around. But I think chops is viable if you're looking for something with better performance and maybe a little bit of a different kind of flexibility that's sort of easier seen. And let me show you that. So I'm going to drop down a chop network. I'm going to dive inside, and we need to operate on our geometry. So our geometry is, if we go up 2 levels, type in 2 chops, and now we're bringing in the position attribute. Let me hop over to my motion effects view. Oh boy. All right. So now we are looking at so this is our channel representation of our position. This is just showing us 3 channels, and what it's done is for every packed primitive, it's brought in the position of that packed primitive as a sample on a single channel. I go into that difference in other tutorials, so I'm not going to belabor that point, but this isn't what we need. What we need, and I'm going to turn this off for a second because you'll see, what we actually need is we need this to be animated. And the difference is between animated and static is, rather than bringing in 3 channels, one for position X, Y, and Z, and then adding a sample per channel for point in static mode, in animated mode, it's going to bring in 1 channel for every point or every packed primitive that we have in our scene. And that's a lot. And this is where one of the main criticisms of chops is, oh my gosh, it's so slow. And it can be. It definitely can be. And this is why. Because it's brought in 2,800 channels and it's trying to display them all at once, which is, nothing can display those efficiently. I do these kinds of operations in Touch Designer a lot as well, and same problem. Like viewport performance tanks when you have thousands of channels represented in your viewport. So the very, very not obvious way to navigate this problem, I'm going to drop down a null, because I want to view the null. I don't want to view what will eventually happen in the middle. I want to view the final result. I'm going to highlight the null. And you can see how slow this is, but again, because of the number of channels. And what I can do is actually turn those off, and now it's very snappy because it's not showing anything. So down here, this is not obvious, but what's going on down here is actually you can think of it as a viewport filter. So this X will say, what do you want to turn off? And I want to turn everything off. And now when I look at that should have done it. I think it only works when you have something highlighted. So now let's try this. Let's say I click on the X, and it takes a minute because again, there's thousands of channels here. Say I don't want to look at anything. Turn everything off. And then you can say, actually, now let me find a single channel to look at. And what I'm interested in is my Y position. And you can see how many channels this is. It's absolutely insane. So I want to just pick a random channel with my Y. And now we can see this is the representation of the Y position of that particular packed primitive. Let's see if I can find a different one that goes a little bit higher. And I'm just choosing randomly. I'm just scanning down until I see Y's and then just grabbing one. And really neither of those are perfect, but it's okay. So now we only have 2 channels in our viewport here, in our motion effects view. And it's not nearly as laggy. It's still not perfect, but it's still not, it's much easier to see what's going on. Now what we want to do is we're bringing in our position here. That's what we've done in this geometry chop. We brought in our position attribute, and it's created these 3 channels from our one P attribute. And what I want to do is I want to add a spring. And immediately you can see on both of these primitives that I'm viewing in our motion effects view, this is the effect of the spring. I'm going to leave this for now. I'm going to head back to our scene view. And now to get that manipulated channel out of chops, what we need is a channel SOP. And I know it always sounds goofy to the language of Houdini always sounds a little bit goofy, but I'm going to call this reference P, because I'm gonna bring in my position from that spring setup that we just did. Luckily, the channel SOP defaults to all its parameters are sort of default set to bring in the position. So all we need to do is take this channel, or take this chop net, drop it into that field, and then point to the channel that you want to reference. And now, what does it tell us? The reason for this is we need to set this to animated. And now what we've got is we will have jiggly positions. And you can see our performance. We're at almost real time, 23 FPS, whereas our MOPs Spring Modifier was around, I think it was like 12. So you can see the performance gain, and the benefit to this is it's not, I mean, maybe it's just a difference. It's not solver based. So once you initially drop down this spring chop, and you go from that to this, that's all the processing that happens. And now back in the scene view, we can even leave this playing and just dial in our settings. and there's a little bit of a lag when you dial it in, but that's obvious because you're changing settings. And what's happening, people, I harp on this a lot. People are like, oh, Chops is so slow. What just happened when I did this, when I changed these effects, it iterated through 2,800 different channels, made changes to them, and it's applying it to our scene, basically with very little noticeable lag. If you're to do that within a solver, it would be a much different experience. So that's, in a nutshell, that's why I prefer to do things like this in Chops. Again, there are absolutely gotchas to that. Now, if you're looking at your motion effects view, or trying to look at it with all 2,800 channels viewed simultaneously, and you're trying to make changes live to this, it's not going to work. It's going to bog down, and it's going to bog down hard. And it's understandable. You got to think about what you're asking the program to do at that point. It's almost as if you were in a really heavy flip sim or something, and you're changing parameters like live while you're playing it back. You're like, oh, this is so heavy. Well, it's obvious it's heavy because you're asking the machine to do, and the program to do, unbelievably complicated things. And it's not so much different. You just got to sort of temper expectations and approach the problem a reasonable way. And I think you'll start to appreciate really what's going on in Chops. So that, and then, I mean, if you just want the basics of how to set this up, that's the basics right there. And you can also you can replace the spring stop or the spring chop with a jiggle chop and get a very similar result. And you can see how quick that was. I just did it live while it was playing back. We can look at the motion effects view and see the difference between the jiggle and the spring. It's not a lot of difference. The parameters are different, but the end result is not. It's not night and day difference. The jiggle chop is set to really only work on position channels. Like if you were to plug in a different attribute into this jiggle chop, it would give you an error and say that it expects TX, TY, TZ. So if you're using position and you want to use the jiggle, that's great. I think it gives just as nice motion. Maybe you can tweak the settings and get a motion that you're more happy with. Either is fine. And now, the other thing that I wanted to go over with this was what we've done here is we've got a nice delay effect on our position. But if you remember, our MOPs setup also has rotation, and right now our rotation is not being lagged in any kind of way. So let's fix that. And also, while I'm at one quick speed up to the MOPs setup. This ignore zero fall off prims. With this turned on, I saw a speed gain with that as well. So just another little tip. So now let's address our orientation. Now, if you look, let me see. Now this is our chops processing. That's what that is. You can see that was still pretty quick. If you look in your geometry spreadsheet, what you can see is when we change, here, I'm just going to go up here and do it. When we change our rotation, what we're really changing is the orientation, or the attribute that's within MOPs that's getting updated when we make changes to our rotation is the orient. Okay, so what we want to do is we want to lag that orient, or we want to apply a spring modifier to that, or a spring chop, I should say. So the way to do that, and it's helpful to see what attributes you have coming in, because you're going to need to specify those within your chop network. So we're still going to reference, this is my chop network. We're still going to reference the same null, but rather than bringing in our position attribute, what we need to reference is our orient attribute. And you can see, like with the example of our position, it breaks that down into three discrete channels. In our orient, we have 4 discrete channels. We have a 0, 1, 2, and 3. So to get those into chops, we need to do orient 1, or actually orient 0. And then I'm going to copy that, do a space in between, paste that out 3 times, and then change it to 1, 2, and 3. And now we're going to do our same spring operation, but rather than call this out P, I'm going to call this out orient, and now we'll come up a level, come back down to our reference. This is where we're bringing in our modified position attribute. I'm going to duplicate that because I need to bring in my my modified orient attribute. And first off, we need to point to the correct null in our chop network, and our channel. This is gonna, it's attempting to bring something in that's not there. So the channel that we want to bring in is orient 0, 0, 1, 2, and 3. And the attribute that we want to apply those channels to is our orient attribute. All right, and now it's happy. So now originally I thought that was all I needed to do, because when I look in my geometry spreadsheet, you can see I have modified. If I select between my pre-chop and my post-chop, my orient attribute is changing. But interestingly enough, if I disable this position, because I don't want to view my lagged or my modified position attribute. Now, if I toggle back and forth between my processed orient attribute and my raw one coming from the MOPs transform, the geometry is not any different. So this was a little bit of a head scratcher for me. And what you need to do to, I'll just delete this. What you need to do to get this applied is you need to lean on the MOPs apply attributes. And what you'll do is you'll just feed your raw geometry into that, and then you'll take the take your processed orient attribute out from this channel reference, and then you'll notice that now you've got your rotation applied as well. So that was the last gotcha for me in trying to get all this to work. But there are tools provided for that. And now if I turn my position back on, we see I have this nice wavy motion. And really just with 2 chops. And this is going 18 frames a second. And really that little dip in performance is coming from this this apply attributes, because we're still at 20, 21, 22 with all of our processed attributes. But to see that rotation, you have to use this apply. I think that I found some way, as long as you if you leave most of the I was trying to tick off anything in here that that may be causing a bit more of a slowdown. One thing I neglected to mention was, if you remember, coming out of our RBD fracture material, we're doing all this processing on our proxy geometry to sort of eke out as much performance as we can in the viewport. But once you're happy with your motion from your delay setup, just as we did to apply our orientation using the MOPs apply attributes, you could just as easily feed that into your high-res geometry. You'll notice a dip in viewport performance, a significant dip. So if I were doing this on a real project, I would just have one set to render, one set to display, and that way you still maintain some decent viewport performance, decent speed there, but you would be rendering your high-res geometry with all the additional edge detail. So I just neglected to mention that difference, that if you were doing this for real and you had higher res geometry, you would want to feed that into a secondary MOPs apply attributes to get all the work you did on that delay transferred back over to your high res geo. All right, so that's sort of the long and short of it here. I think, like I said, the reason I really like this is being able to see this representation of what's happening with the spring modifier is really beneficial to me, to sort of have an animation curve representation of that jiggle is really, to me, that's very valuable. And also to be able to apply the same delay effector kind of mentality, to be able to apply that to any attribute that you want, rather than just the position, which is what the jiggle chop, what that wants, really the only attribute that wants to read in is position. You can rename attributes coming in and rename them going back out, but that becomes pretty cumbersome. And again, the difference in these, as we saw earlier, is really not a big difference. So again, thanks for watching. I hope this stuff is valuable to the way that you work. Thanks to Henry for making the MOPs toolset, and what a great resource that's been for really anybody doing motion graphics with Houdini. If you want more information, or if you want to get notified when I put out more information, give me a follow on Twitter, follow me on or subscribe on YouTube. I've put out a lot more content this year. I'm trying to keep that up. I've got to balance workload and life and all that, but there's definitely more stuff coming, more stuff I'm excited to share. So thanks again for watching. I hope this was helpful.